We are going to run through some theory in this video in relation to token-based authentication. Normal basic authentication is based on a username and password being sent with every request. Because this is sent with every request, there is a high risk that the password could be exposed. Because HTTP requests are stateless, and therefore REST APIs also stateless, we need a way to allow users to send something to the server with every request that is not as sacred as a password, and this obviously will only have a limited lifetime. This is where an access token comes in, and over the next few lessons we will be refactoring our API that we have created to handle token-based authentication. This will include being able to create new users, log in, log out. Each task will belong to a user, so for a given user, they will only be able to view, update, delete, and create tasks that belong to them. So what is token-based authentication? A token is like a password with a limited lifespan. When a user authenticates with a username and password, they are given two tokens, an access token and a refresh token. An access token has a really short lifespan, usually minutes or hours, and a refresh token is valid for a lot longer, usually weeks or months. Both tokens are usually just a random set of base 64 encoded characters, for example. This random 64 encoded string is sent in the HTTP header. This is used as a password to authenticate you for every request. But when an access token expires, you will then use the refresh token to get a new access token. This also comes along with a new refresh token as well. So the reason why the refresh token has a longer lifespan is because once it's sent to the client, it is not then resent on every request and response. It is only ever resent to get a new access token, so it is less likely to be leaked or exposed to a potential hacker. We also have to take into account sessions. We use sessions so that we can use a system from multiple devices at the same time. If you have ever used Facebook or another social networking service, you will know that you can be logged in on both your computer as well as your smartphone at any one time. If we didn't have sessions, then if you move from using Facebook on your computer to then your mobile phone, it would ask you to log in again, and this would log you out of Facebook on your computer. This would not be good from a user experience perspective, and also can increase the likelihood of a password being exposed, as you'll be sending the password every time you switch devices. Now what we're going to do is go through the flow of how token-based authentication will work in our API. This will give you a good idea how to implement it in your APIs. So this is the flow diagram here. Now you can see the client is here, the authentication API is here because it's not part of our resource API. The resource API is basically the API to get the tasks and to update tasks. The authentication API is what we'll be using to submit login requests and user requests. So we'll have its own controller. So as you can see down this left hand side, these are the user actions. So log in, get a task, refresh a token, get a task and log out. So the way that we'll be using the authentication API is to send a request to post sessions. So post, remember, is used to create. So we want to create a session. So /sessions, and we'll be sending a username and a password in the request body of the HTTP request. So it's just JSON format. So username, that's a username, user123, password, and that's a password. So we'll send that the authentication API. The authentication API will do the check. If it is an error, which is what the red dots are here, these are sort of error clauses. So if there is an error, you'll get an HTTP status code of 401 unauthorized back to the client. Then you'll get an error message, username or password is incorrect. However, if that user123 with password123 is valid, then what happens is you get a 200 status code, which is an OK message back to the client. The details returned in the response body is a session ID, your access token here, your token expiry because it only has a limited lifespan, and that's in seconds, your refresh token, and your refresh token expiry. You can see that the refresh token expiry is a lot longer than the token expiry. So now that we've got our access token and refresh tokens, we'll try and get a task for our user. So we're moving on to get task. From the client device, we use the /tasks/2 to get task 2. And obviously these are the API endpoints that we've just built in previous sessions. However, on this request now, we'll be sending an authorization header value. So as an HTTP header, we'll use the authorization. and that will be our access token. So you can see here it's ABCD123. Now that's not a valid access token in the real sense, that's just for demonstration purposes here. But you can see that is our access token for this session. So we send get/tasks/2 to our resource API. So that's our tasks API that we've built. That does a check to make sure that it's a valid user and that the access token is valid. So you can see here, if it's not valid, we get a response back of 401 unauthorized, and we get an error message, access token is invalid or expired. We don't want to give really too much away regarding error messages. We don't want to be too specific, especially when authentication is concerned, because people can use that and check out error messages to target exactly what's wrong, whether it's a username that's incorrect or a password. We'll basically just say username or password is incorrect instead. If this authorization token or access token is correct, we'll get a 200 back, just like we normally do. Task ID and then obviously your task details there, like we have in previous sessions. Now, what happens, obviously that access token is only valid for so long, say 20 minutes or so. If, you may have lots of task requests going on, you might be updating tasks, you might be getting tasks, you might be deleting tasks. Now, after 20 minutes, that access token will, start to run out of time. So what we have to do now is refresh the token. So what the client should do, because the user should never know this, how this works in the background, the client should handle this. The client should know that the access token is approaching its expiry time. When it's close, really we shouldn't allow it to run out, but you can do, as long as the client handles this. So once it starts getting close, what should happen? The client should check and go, right, okay, we've only got about a minute or so to go before the access token is expired. So what that'll do is send a refresh token request to our authentication API. Now the way it does that is use the patch. Remember, patch is used to update, and we're updating our session. So where we've got /sessions/3, that is a session that was created when we first logged in up here. So we've got sessions_ID is 3. So we know that our session is number 3. What's sent with the refresh token request is the header for authorization, and that is our current access token. Even though, it might be expired, it doesn't necessarily have to be still current, it might be expired. And then in the body, we will send the refresh token. Like I say, we only send this refresh token when we need to refresh the access token. Otherwise, it's just stored securely on the client device. So we send this refresh request to the Authentication API, and the Authentication API will respond back 200 OK. I mean, obviously it could error, but we're just, for quickness, just showing you here that it's an OK. Session ID 3, so it returns the session information again. It's still the same session, we're not creating a new session. It is still the same session. However, we get a new access token. New, obviously, token expiry time in seconds. But this time we also get a new refresh token, and obviously a refresh token expiry. So now the client device will store this new access token and refresh token ready for the next set of requests to the resource API. So the client just, plods along as normal. So get /tasks/2. However, this time you can see that the authorization token is the new one. So your resource API goes, okay, I know that's valid because I've just created it. So it returns the task back to the client. Once you're finished with that session and you want to log out of the application, although a lot of people don't log out of applications these days, they stay logged in, which is fine because our access token and refresh token is stored on the client device. Now, our refresh token will be stored, is valid for, say, a month, say 14 days. That's totally up to you. I mean, you wouldn't have an ongoing, 3 years or so refresh token valid. You would have like a limited sort of time scale. So say 2 weeks or 30 days is probably ideal. So if there's no activity within 30 days or until that refresh token expires, then when the client opens the device again, opens the application, it can carry on with this sort of session here. So after 20 minutes, if you haven't used the device, the access token will be invalid, so the client will automatically request a new access token based on the stored refresh token. Now, if the refresh token has expired as well, so say you haven't used the app within 30 days, then when you open the app, it should basically log you out of the app and go back to the login screen for you to log in again. You probably noticed that on some websites or some apps that you use. If you haven't used them for a while, they'll automatically log you out. So if you're still logged in, we'll go back down to this part. If you're still logged in and the user clicks the logout button, we now want to get rid of the session that we have, so session number 3. So we use the delete HTTP method for this. So delete /sessions/3. Now all that's needed for this, because we know which session that we want to delete, is the authorization token. Now at this point here, we're not really bothered whether this authorization token or access token is valid, because we are just logging out. If it wasn't valid, there's potentially that you could have a rogue session on the server somewhere, and that's not what we want. Basically, if the access token matches the session, then it should just delete it whether it's still active or not. So once we send that request, we should get a 200 back, okay, and then the session that we've logged out of is session 3. So I know that's a fairly basic flow diagram there, because there's a lot more that can go on with a user experience, but I couldn't fill it all on the screen, to be fair. So what I've done is just cut down to some of the basics, but hopefully from this diagram you should be able to see how we're going to implement the Authentication API and how the flow will work as we're going. Okay, so we'll start building the authentication functionality in the next video.